So vector map layers can be either point, line, or polygon. And we can look at how those are represented by the nodes and the vertices that make those up. If we have point layer as vector layer, point layer that is vector, each point has an x and y coordinate associated with it. So we can represent any point just by an x and y coordinate or latitude and longitude, any two coordinates that will uniquely identify that on the surface of the Earth. For a line, we have a beginning node where the line starts to be drawn and an ending node where the line ends. Every place it changes directions in between, we have a vertex, and the plural for vertex is vertices. And you can see that these are all straight line segments. So if we want something to look curved, we just add more of these straight line segments at very small partitions until the line itself looks curved. With a polygon, we have a closed set of lines, so it closes in on itself, and the beginning node and ending node in that case would be the same. With, once again, every time we change directions on a line segment, that would be a new vertex. This just shows how we can use that to represent the real world. Here we have an area with a road and some houses and a lake, and we're able to represent the house as a point, the road as a line, and the outline of the lake as a polygon. So this is kind of the geographic side of GIS. But then, in addition to that, each one of these features here, whether it be point, line, or polygon, also has an attribute table and features in the attribute table associated with it. So let's look at this example. Here we have a map of where a series of fire hydrants are within a district, and each one of those fire hydrants has a row and an attribute table associated with it. In addition to the row, which is the feature, it can have as many of these attributes as we would like it to have, with each column of the attribute table representing a different attribute. So in this case, each one of these fire hydrants has a attribute called flanges, color, and rating. And we can, if we clicked on this one point here, we would see what the values were for that. In this case, 3, red, and high. So whether it's point lines or polygons, each feature that we see on a map, whether the feature is one point, the feature is one line, or the feature is one polygon, we see for that point an associated row in the attribute table, we see for this line here an associated row in the attribute table, and we see for this polygon here an associated row in the attribute table. Each feature has a row in the attribute table, and it can have as many attributes as we would like to give to it. One way to quickly see this connection is that we can select something on the map and it appears in the attribute table, or we can click on something in the attribute table and that feature will be highlighted on the map. It's an easy way to kind of communicate between the two, that these links and these connections can be made, and it makes working with GIS data very helpful with that. So when we're representing something on a map, should we represent it as points, lines, or polygons? Well, it just depends. Part of it is the scale of the map that we're looking at. If we're trying to map something in a very detailed level, we would probably want to represent as much about that as we could and try to outline those areas. So in this case, these polygons would each represent a separate building. It could be mapped with lines, although if these lines close off on themselves, they're probably more appropriate to be polygons, but we could just put on the outlines of these buildings if we want to. But if we were going to zoom way out on this area and there was no room to show all the detail of what the buildings looks like, we might just want to put in each of those buildings as a point. So there's no hard and fast rules for what is a point, what is a line, and what is a polygon on a map, but it's just what you're trying to show and what level of detail you're able to show in your map.